All right, welcome everyone to this session before lunch. It's great to see so many of you. My name is Per Øvergaard, and I will entertain you for the next hour and 15 minutes. 15 minutes, not 50. And this session is about domain-driven design. First, a few words about me. I call myself a developer and an architect. I occasionally write on a blog, programmaticallyspeaking.com, and I have a Twitter account as well. I have a PhD in software engineering from Blekinge Institute of Technology in Sweden. And I work as a consultant at a company called Factor 10 in Sweden. The main message I have during this presentation is dare to challenge development habits. Now, what does that mean? It doesn't mean change your keyboard to Dvorak. It also doesn't mean challenge everything and do everything different, do anything however you like it. Because when we develop software, there are certain constraints. And the constraints I'm thinking about can be divided into two different groups. There are negative constraints, and the negative constraints are the ones that we should challenge as developers. One such constraint is the standard approaches, how we've always done it. When you do software development, you have a certain knowledge and history with you, and you tend to do things the way you did it before. Use your standard approaches. The problem with doing that all the time is that it sort of prevents creativity. You won't get any new good creative insights by just doing what you've always done. And a related thing is being in your comfort zone. If you stay in your comfort zone, the same thing applies. You won't get any new creative insights. Just-in-case development is one of my favorites. Have you heard of it? It's when you develop software and you write a lot of code just in case you need it in the future. There are a number of principles that are good to follow when you do software development. They're YAGNI, you ain't gonna need it, and KISS, keep it simple, stupid. And just in case is the direct opposite of that. And we see it all the time. Another constraint that I hear a lot and I see a lot is that when we do enterprise development, everything needs to be big. And while it's true that in an enterprise situation, systems are typically big, that doesn't mean that all the constituent parts need to be big or that the solutions need to be big because all the problems are automatically big. There are cases in an enterprise context where you can solve small problems using simple, small solutions. These are constraints that I say challenge these. Don't play it safe, do new things, try out new things, and you will get creative insights and learn more. And then there are positive constraints, things that are good in constraining our development. One is your current knowledge level. If you know very little about something, well, don't go ahead and do something big and fancy when you don't know what the problems are and what the technological constraints are and so on. And don't ignore the characteristics of the domain. If you're in a telecom domain or in a banking domain, there are certain characteristics of those domains that you need to adhere to, that you need to let influence your development effort. And of course, perhaps the most important of them all, the value for the customer, for the business. This is something that is extremely important. You must always achieve high value, and challenging that is not a good idea. Now, during the presentation, I have a story, and the story takes place at one of our clients. It's a big client. They have a big enterprise system, but there is a problem with the system, and the problem is, or one of the problems, is that their code is not in control. And that means that they have very much code. I would say more code than is needed to solve the problem, and the developers struggle to keep the system floating, sort of. This is not unique for this client. We see this a lot at all of our clients. Perhaps you have heard of it or read about it. Anyone? Yeah, a few. So the client was in the process of replacing an old system, they had functionality in an old system with roots in the previous century, and they were building a new system and gradually migrating functionality over. This is also something we see a lot. I bet that all of you, or some of you, have worked in situations like this. Take this old system and replace it with a new one. Happens all the time. So the story is essentially about us building a piece of the new system. So we took some functionality from the old system and migrated that to the new system. Now, if the client would do it themselves, then they would, of course, build that functionality, or let's call it the subsystem, using their standard approach, their standard architecture, the architecture that they apply to all their systems. And it would be an architecture with multiple layers, perhaps 10 or so. And they would use a pretty conventional OR mapper to talk to the database. The server and the UI would communicate privately using WCF communication. And the system would be very much database driven. So sort of the design would start with the database, and then things would sort of go from there. The service layer of the server part would be very fat and contain a lot of code, and the system wouldn't be very model-centric. Now, I think this describes a lot of systems. When I gave this presentation in New Orleans, people came up to me afterwards and said, "You're describing our system. This is exactly like the one we have." So anyone here recognize this situation? Yeah, a lot of hands. Okay, cool. Now, there are a lot of problems here. Multiple layers, well, that's one thing. The problem here was that many of the layers just shuffled data back and forth, so there were uninteresting layers that didn't really add anything to the value of the system. And so the UI wasn't allowed to see objects from the server, so the server would pass data sets up to the UI. But there was an entity model in the server, so what happened was that the OR mapper would read data from the database, convert that into an entity model, and then there would be a layer that converted back into data sets and send those to the UI. So there were a lot of model transformations going on. Now, if you see the picture, this looks pretty neat. It's a fairly isolated subsystem, so it looks nice partitioning-wise. When you open the database, however, all the subsystems would sort of touch each other's tables and read data from each other's tables. So while the partitioning looked nice in pictures, it would sort of fall apart in the database. And business logic, business rules would sort of be scattered in many different places, a lot of them in the service layer. And it wasn't very well tested. So changing anything, any code in a system like this was very dangerous because you couldn't really anticipate what would happen. And now we said we don't want to build a system like this. So when we migrate this functionality from your old system, we want to do it in a different way. We want to keep things simple. So let's only use few layers, the minimum needed, remove uninteresting layers that don't add any value. Keep it tiny, the code size. Remember I said that the code wasn't really in control because there were more code than needed to solve the problem. So we said that let's sort of focus on minimizing the code. We wanted to have a deep model focus. And I'm not talking about the data model here. I'm talking about a model where we would sort of have our business rules and business logic. This is a model that I will talk about more in depth in a couple of minutes. So we wanted to get away from the database-driven approach. And we wanted to use that model across the system, from the UI to the storage. So we wanted to avoid a number of model transformations and keep things as simple as possible. We wanted partitioning to be very strict, so that if you looked at the subsystem, you would say that this is a subsystem in isolation, also in the database. So the data owned by the subsystem in the database wouldn't be possible for another subsystem to sort of go into and read and write. Now, we used the same basic technologies as usual, so we kept the WCF communication between the subsystem, the UI of the subsystem and the server. And we used the same database technology, Microsoft SQL Server, but we dumped the OR mapper. Now, what's not shown in the picture is that the subsystem would sort of have services to talk to other subsystems, which I refer to public services. And for that to work, of course, you need to have some sort of format, interoperable format, such as datasets. But when you communicate between the UI and the server, the communication would be entirely private, meaning that the UI would be the only consumer of the service that blue arrow there represents. And we also wanted this to be well tested. A lot of tests so that whenever during maintenance you would go in and fix something, add a new feature, you would be certain that the existing functionality didn't fall apart. So instead of doing it the standard way that the client would do it and do something very much database-driven, and I should add that sometimes database-driven is okay, not in this case, we chose to use domain-driven design, challenge the habits of the client, do things a little bit different, and show them how you could do instead. And the result was excellent. So let's start by talking about the domain model, what that is. And before that even, let's talk about what not to do when doing domain modeling. One thing that I see a lot is big upfront design, where you sit down during the initial phase of the project and you try to think ahead and you create a big model that captures everything that you can possibly think of. Do you recognize that? Have you done it sometime or seen colleagues do it, perhaps? Oh, a few. This leads to something called speculative modeling. You don't know everything in the beginning, so you will sort of guess and try to guess situations and build a model based on that. And as I said before about database-driven, you start by creating a data model and sort of structure your database, and then sort of you derive an object model from that, and you derive everything from the data model. Which is not good, because they are sort of entirely different models. What works in the data model may not work in an object model, and vice versa. So trying to sort of keep this the same is not a good idea. And as I said before, scattering domain rules, domain logic, keeping that in a service layer, and the model contains sort of mostly data objects, properties, public, get, set. So this is called an anemic domain model. And what happens is, of course, that when you put rules and logic in the service layer, then you sort of tie your business logic, business rules to the technology used to expose data to a client. So you mix mechanisms and your business rules and logic. This is not something you should do. So what is a domain model then? There are a lot of models. I talked about data model and object model. And a domain model is not only that. A domain model is something more. When you develop a system, you have a problem domain, the domain in which you do business, telecom, banking, anything. And the domain model captures everything within that problem domain, from rules and behavior to language to limitations. Everything is captured in a domain model. Which means that the domain model is more than just what you see in the database and what you see in the code. There's much more to it. And when we work with the domain model in domain-driven design, we want to make sure that the operations on the domain model are semantic, that there is some sort of business significance to the operations, to how we interact with the model. And to give you an example of what I mean, consider this, the thing on top compared to the thing on bottom. So let's say that we have an entity in our domain model called account, and the account has a balance property, and it's public, get set. And we say that balance minus equals 50. So we withdraw 50 from the account, from the balance of the account. Sorry. The problem with that is we don't know anything about what 50 is. Currency, is it dollars? Is it euros? Is it something else? And while there could be some sort of rules and validation in the property, the chances are that there are not. So we could violate a lot of business constraints and rules in this case. Compare that to the operation on the below, where we say that we have an account and we interact with it by saying withdraw, and then we pass something in. We don't just pass 50, we don't pass the number 50, we will pass something, 50 of something, so in this case $50. And as you can imagine, when we interact with this model, we might as well said that we would pass in a number of euros, and the domain model would perhaps be capable of converting between currencies and adjusting the balance accordingly. And also you can imagine that if the account didn't have enough money in it, you would get some sort of error back and so on. Now, what you see on top is sort of a characteristics of an anemic domain model, where the model is only data, so you do a lot of data access and modify properties, but in order to keep things neat and tidy, you need to do all the validation and rule checking outside. Now, if we take one step back and talk about models in general, I found this very nice picture of a tree on Flickr. I like it very much. There are so many good things about it. And I said that to me, this is a reality. This is something, this is our domain. And I wanted to model that domain. So this is what I came up with. And it's actually me who drew it, not my kids. It took me a long time to get this nice model of the tree. And there are a number of things that are interesting here. The first one is that the model and the reality, in this case the domain, are very different. So if you compare these two pictures, you see that there are a number of things that I haven't really captured. I hope you can agree that it's a tree. So in a way, it sort of reflects the domain. There is a trunk, there are leaves, and grass on the ground, there is a ground. But there are a lot of details that are left out. Because when I model a domain, I only want to model the relevant aspects. And in this case, for me, it was the fact that it's a tree, that it has a trunk and leaves, and that it stands on the ground. I chose to omit the fact that there is a shadow caused by the tree. I chose to omit that the tree leans heavily to the right. And I also chose to ignore the fact that the leaves there are very many details in the leaves, and in my model it's only sort of a fluffy thing. But when modeling this domain, I said this is what's relevant to make it look like a tree. So I left out a number of details. And this is something typical when you model a domain. You cannot really try to model everything. You will fail. Because it's simply not possible. You only need to capture enough in the model so that you can solve the problem that you have. So in this case, it wasn't relevant that the tree was leaning. When we talk about domain-driven design, there is one very important concept called bounded context. And bounded context is one of the strategic patterns in DDD. And it's sort of a context in which a domain model applies and lives. So if you consider the tree picture in a previous slide, I said that this is what I chose to model from the domain. That model would apply in a bounded context. And then someone else in here could have a different bounded context where they would model the reality differently, where they would choose to model the fact that the tree leaned to the right and that there is a shadow cast by the sun. In an enterprise, you typically have multiple bounded contexts. So as a consequence, you will have multiple domain models. So even if you have one single domain, you need to sort of partition that domain into subdomains and choose bounded context to implement different domain models for different aspects of the domain. Think order system, inventory, sales, etc. the notion of having one big domain model for the entire domain is not something you should strive after, because that is bound to fail. You cannot really capture everything about a big domain in a single domain model. So this is very core to domain-driven design. And I will go back to some more aspects that relate to bounded context. Now, in these cases here, we can have concepts in one domain model, such as client, and we can have that in the other domain model as well, but they mean different things. Or tree in domain model 1 and tree in domain model 2, but they mean different things. That's perfectly fine. When I do software development, and when we built this system for the client, we chose to have sort of extreme domain model focus. And this was in part sort of to really set a contrast compared to what they had before. And the question is, how many models do you need? We have a lot of models when we do software development. We have view models, domain model, object model, data model, entity model, whatever we want to call them. Models, models, models. And if you communicate with other systems, you have models there as well. And we said, let the domain model permeate the system. Let's implement a domain model and use that in as many places as we can to avoid model transformations that don't add value to what we're doing. Now, this doesn't mean that you shouldn't have other models, that it's forbidden to have other models. It just means that if you don't need a different model, then defer creating it until you can justify that you need it. So take the view model, for example. You probably need a couple of view model objects. So by all means, have a little view model where you have a few objects. But if you can use parts of the domain model in your UI, why not do that? Sometimes I see people mechanically creating view models that is sort of a one-to-one mapping between the domain model and the view models. And so there's a lot of code just mapping back and forth, not adding value. So at the client, what we wanted to avoid, what I mentioned briefly before, was the dataset shuffling. So the client would given the entity model that they got from the OR mapper, they would code sort of a layer where they transformed that entity model into a dataset again. And then they would pass that dataset to the UI. And this led to bad performance. The transformation took a long time. It was error prone. And coding towards data sets is sort of suboptimal. It's not a good programming model. So we said, instead of shuffling data sets to the UI back and forth from the server, let's shuffle domain model objects. And the reason that we said this is okay to do is because the link between the UI and the server was a private link, private communication, and the only consumer of the service would ever be the UI. And they would be deployed together, so it sort of was just the fact that there was a WCF communication was just an implementation detail. And then we could have rich domain model interaction in the UI. Instead of interacting with data sets, we could interact with the domain model in the UI, and we could even, to parts of it, bind in the UI to certain objects in the domain model. Not everything, but some parts of it. And then we said, let's also do that in the database. So instead of having a very low-performant, inflexible database where everything was connected to everything else, if you opened the lid and you sort of pulled in one table, then everything would follow. And as I said, the systems would write and read to each other, to and from each other's tables. The mappings would map to the same tables, but sometimes using slightly different mapping rules. So it's not a good situation in the database, and there were a lot of problems with that. So we said, let's just dump the object graph in the database. Sort of a NoSQL solution, but within SQL Server. We just serialized the objects down to the database, and through that we could achieve a very strict partitioning so that no other subsystem could go in and read and write our data. And the end result from this was that we had a very low ceremony. Do you know what that means? Anyone? What does a low ceremony mean? Yeah? Louder, please. Okay. Sorry, I didn't hear that. I guess that you said that ceremony is about, writing a lot of code just because you have to make certain things working, such as transforming, mapping properties to other properties, back and forth. We wanted to avoid all that. The code we wanted to write should be related to the business and provide high business value. And also, we could have minimal context switching, because if you have to deal with a view model and a data model and an object model and 2 or 3 other models, developers have to context switch between these. And when they see one model, they have to think how sort of the concepts are represented in that model. And normally, to avoid that, the developers make sure that all the models are the same. So, as I said before, they have a data model, and they just derive the object model from that. So they're essentially the same, even though that's not a good solution. Now we could avoid that in a different way. We could have a very simple data binding in the UI, and it turned out to be an excellent database performance. So this was a really good situation. Now, I mentioned one domain-driven design pattern, bounded context, and there are more. When you talk about patterns in domain-driven design, you usually talk about 2 types. There are strategic patterns, and bounded context is one of them. It has to do with your high-level architecture and how that looks. And then there are tactical patterns, which are more in detail how you implement your domain model. And I'm going to talk about a few of them and then show some code. First, what not to do. If you have your object model, everything is connected to everything else, so you can traverse your entire object model just through association. So to start with a company, you get the customers from the company, you get the first customer, the orders of that customer, the last order, you get the order items, and then you sum over those. To make this work realistically, because you can't really load everything from a database at once, you implement lazy loading. So you instruct your OR mapper to lazy load these parts. So when you hit the customer, it lazy loads orders and so on and so on. So what you do is essentially that you tie your OR mapper into your domain model. I don't like this at all, because it's very flexible, but it comes with a price. Everything in the model is first-class object. So everything has a unique ID, and you can take anything you want, load that from a database, interact with it, and then save it back. It's very flexible, but it's also very difficult to sort of adhere to your business rules. If someone can load any object from a database and interact with that, how on earth are they supposed to adhere to your rules and your logic related to that? And since we don't know really how everything hangs together, we need to wrap everything in transactions, just to be safe. Now, the solution in domain-driven design for this, to avoid these problems, are something called aggregates. And as the name suggests, an aggregate is sort of think of it as an object graph where you have several objects in. So you have entities, but you also have something called value objects, which I will get back to in a minute. And these entities and value objects are they hang together. So within our domain model, we define tiny pieces of it that are very highly coupled to each other. And you identify an aggregate through its aggregate root. And the root is one of the entities in the aggregate that is the only thing that you identify ever. And one important aspect of the aggregate is that it's internally consistent. So that means that a client, or let's use a different word, a user of your domain model, so to say a programmer, can't really go into the internals of the aggregate and do just anything. Because internally consistent means that the aggregate root determines exactly what can be taken out of the aggregate and sent into the aggregate. And by doing that, it can make sure that all the business rules that apply to the aggregate are adhered to. So you can't reach into an aggregate, pull something out, modify it, and put it back. You need to go through the aggregate root, and that sort of is a protection boundary around the aggregate. we persist the aggregate as a whole. By doing that, we mean that your data layer doesn't allow you to load something within the aggregate and modify that directly and then put it back. We only load the entire aggregate so that we can get the protection boundary held by the aggregate root. And when we do transactions, we say that we save the aggregate with we save the aggregate within a transactional boundary. And when it comes to interaction between aggregates, we can use something like eventual consistency, so that things don't need to be consistent right away. They can be consistent at any later point in the future. Now, designing your aggregates is not easy. There are many things with domain-driven design that are sort of difficult to do the first time you do it, because it requires very much practice. But once you get your aggregate boundaries right, you will find that that gives you a very clean separation of concerns in the model. You come up with isolated pieces of your domain model that are sort of mini models in themselves, so to speak. And I found that the idea that it should be internally consistent and that you should wrap things in on transactions are very good drivers for designing an aggregate. Because if you say to yourself that when I change this thing in my aggregate, I really need that other object to sort of be affected as well, then perhaps that should be in your aggregate. And if you say that when we save it, I really need to make sure that this other object is also saved as well, then perhaps that should be within the aggregate. And just making one big aggregate out of your domain model is not a good idea. That is the anti-pattern we had before. And once you have this, you can load everything eagerly. Skip lazy loading. And this is also a good driver for aggregate design, because if you think that's stupid because then I need to load so much data, then perhaps your aggregate definition is too big. It involves too much. So these are some good things to think about when doing aggregate design. Now, within the aggregate, you can do associate traversal. So you can, from the root of the aggregate, you can reach other parts of the aggregate as long as the root permits it. So the aggregate root has full control over who uses the data in the aggregate and how. I mentioned value object. Value objects are really good things. The thing with a value object is that we define it by logic and by data alone. There is no identity in a value object. So that means that when you have two value objects and they have the same data, they are essentially the same thing. And in the .NET framework, there are a number of these value objects. Anyone can give us an example? You have to shout. String? Yeah, I was thinking specifically types. Color. Color is one. Datetime. I heard datetime. Good. There are a few. Color, datetime, point, I believe as well. If you have two datetime objects, both representing the same date, they are essentially the same thing. There is no identity to a datetime object. And the same goes for a point. If you have two points objects that refer to the same point in space, it's the same thing. One thing you should do with value objects is keep them immutable. And the thing with an immutable object is you can't go in and change the state of the object once it has been created. And that has so many benefits, because all of a sudden you can just share your value objects freely with anyone, because you know that no one will be able to sort of alter anything. If you have immutable objects, they are automatically thread safe, because threads won't be able to change anything. So keeping these immutable is sort of essential. And as related to that, side effect-free operations. So if you have a datetime object and you say datetime.now.addMinutes5, you won't affect the now instance, which would be a very strange thing to do. What happens is that addMinutes returns a new datetime object to you that sort of is 5 minutes in the future. And the original now object is left untouched. So think of point, for example. You can say point offset and offset that point different to a different point, and instead of changing the original point, you will get a new point with a certain offset from the first one. Strings is another thing. Strings are immutable. So when you have a string, you can't go in and modify a character in the middle. You have to get the characters from it, which is a copy of the internal characters array, modify that, and then create a new string from that. And someone mentioned structs. Structs in .NET have value-based equality by default. So if you just create a struct and you add in a couple of members, then there will be a default implementation of equals and get hash code that does essentially what you expect. Now, that's not entirely true because it doesn't work for all the members. So if you put in a list, for example, or something, sort of a deep structure in your struct, then the default equality implementation won't be able to handle that. And also the default equality implementation is reflection-based. So you might have a performance issue there. And also if you use structs, then you have, of course, the thing that you have value type semantics, which is a different thing. So you get more than just a value object, you get something else as well. Then we have something called repository. And a repository is essentially just an abstraction. It's sort of a data layer thing. What we say is that one repository is specific to one type of aggregate. And it contains a collection of instances of that aggregate. And as you would expect, we have operations for loading an aggregate and for saving an aggregate instance. And as I said, once we have defined an aggregate, we load and save it as a whole. So what you get from a repository is the entire aggregate instance, eagerly loaded. Just with anything in the domain model, you want to have semantic operations. Now, on any repository, you would normally have sort of get by ID and such, but also other methods that sort of communicate the intent of what the method is doing. So get ongoing projects, get project with name, instead of just get projects and get an IEnumerable and just doing link on that. In addition to providing sort of a good programming model where you can see the intent of calling a method, the repository can also optimize queries, for example, related to fetching ongoing projects and keep so that you can get everything as fast as possible. So I thought I'd show some code related to these patterns. And what I have here is some tests for a simple inventory. So I created a simple inventory, and an inventory consists of inventory items. It's very simple. So we create a new inventory for Gabriel Threepwood, and that inventory has an owner name. And we can also add something and say that when we add an inventory item, a jog or grog in this case, then the inventory, for some odd reason, keeps track of the number of red items in the inventory. And this is, for demonstration purposes, not counting the number of red items currently in the inventory. It's a counter that is updated when we add and remove. Now, as you can see here, I've chosen to if you look at the second line, I pass in a color and a description of the inventory item. I don't pass in an object representing those. I could do that as well, but what I want is, because inventory is my aggregate root for my tiny little aggregate, and I want that to have full control of the data passed in. If you pass in something, an object, to a method like this, you need to make sure that the receiver then gains full control. And that might mean that you have to clone or do other things. So in this case, I just put in my individual properties, and then the inventory will sort of store that in the way it sees fit. And then, oops, I'm on the wrong keyboard. And now we can see that when we when we remove something, the count goes down. So what I do here is that I add a jug of grog, which is red, and then I remove the same thing. And I don't really care, because you can imagine that I had added a number of jugs of grog, right? 5 or 10. And then I remove one. And I don't care which one. These are not entities that I care about identifying. These are just inventory items on a table, and remove one of them. I don't care which one. So that is why I can pass in my properties like this. Now then, as I said before, I want my aggregate root to maintain full control over what happens in the aggregate. That means that I want someone shouldn't be able to tamper with the contents of the aggregate. So in this case, what I do here is that I have an items property that sort of exposes the items that are in the inventory, and I do clear on that. Now I've wrapped this in a little helper that ignores any exceptions, because I have a version of this that, as you can imagine, doesn't allow this, but for now it will go through. And then I have a method that counts the number of red items, and I have my cached number of red items, and this should be the same, because no one should be able to tamper with that list. And the same thing here, down here, in the next method, I say that I set the color of an individual inventory item, change that from red to green. And just ignore the dynamic mumbo jumbo. It's just because a separate version of the code should be able to run as well. So this is another way to tamper with an object, to modify the internal properties of the value object in this case. And I don't want that to be possible. Now if I run the tests here, there are two tests that fail. One is that apparently I could tamper with the items list. I could go in and do clear, and what happened was that my count number of red items says that there are no longer any red items in the list, obviously because I cleared it. But my cached number of red items hasn't been modified, so that is still 1. And the same goes for the second failing test case, which is one down here. Apparently it was okay to change the color of an item from red to green, and the aggregate root happily allowed that. So these are two problems that I need to fix, because otherwise my aggregate is not well designed. And we can look at what really is going on. And what happens in here, this is pretty simple stuff. I just create an inventory item here, and I check if the color was red. I increment my counter. Here is something to remove an item from my inventory. I first need to find an item. And to find it, I need to go through my items list and see that I have an item with the correct color and the correct description. It's a pretty annoying thing to have to do. And then we can see down here. So here's the items property. And as you can see, what happens is that it just returns my items list right away. So even if it doesn't have a public setter, it returns a structure that in itself is sort of publicly accessible by anyone. And that is, of course, a problem. So what we can do to make things a little bit better is to wrap my list in a read-only collection. And that will, as you might expect, make that test case go green. Now I can no longer tamper with the items list. I can't do clear. That won't have any effect. Actually, it will throw an exception, but so it's not possible to do. But in order to get my last test case to go green, I need to do even more, and that is that I need to clone. So what I do here is that I just create a new inventory item that is a copy of the existing item. And at this point, I can just run my code and everything will go green. Now, the reason I have to go through all this is that my value object, well, the one problem was, of course, that the items list wasn't protected. Another problem which leads to the cloning thing is that, that's the wrong one. Is that my inventory item is not really a good value object. It's just a class with two public yet set properties. And there are a number of problems here. So this means that obviously we can go in and change the color and change the description. And there are other problems as well. As you saw in the inventory aggregate root, what I have to do is this new inventory item and copy properties. And up here I had to compare properties one by one. And having this scattered all over the code is, of course, extremely bad design. What we need to do is move cloning and equality checking into the value object. So a better approach then, if we turn to release mode and look at the inventory item now. So what I have here is a true value object. So as you can see, I created a struct. And once I do that, I get this value object semantics. So now, since structs automatically inherit from system.valueType, and that provides me a default implementation of equals and get hash code, I can compare two inventory items for equality automatically without implementing anything. And I've also made sure that my properties are private and that I can only initialize through the constructor. I also added a method for red checking, which sort of is a way of moving that functionality into the object itself. And what happens now is that I still need to keep my read-only collection because I still need to make sure that the list itself isn't tampered with, but I don't need to clone anymore. I can just give these inventory items to anyone who wants them because I know that they cannot change them because they're immutable. And another good thing is that since we have a default equality implementation, I can just do this. So when I say remove inventory item, I pass in a color and I pass in a description. I just create a new inventory item, a temporary one. And I give it those properties. And now, since I know that this will be equal to any existing item with the same properties, I can just do index of. So the find index method is no longer needed. So this is a much simpler solution. And hopefully, of course, all my tests will go green now. Yeah, they did. So what happened now is, yeah. All right, so this was just a small taste of aggregate root, and value objects. Another thing is, of course, our repository. So I have a small interface for that. So here, as I mentioned, we have semantic operations. So I can say that load repositories that are owned by someone. And I can also say load repositories that are mostly read, whatever business rule that is that says that is something good to do. And I can save an inventory. And notice that I get entire inventory aggregates back. That is my aggregate root, and it will sort of contain everything in the aggregate. So I will come back to this a little bit later to show you some more. Another thing which is very dear to me, and which I think is very good to keep in mind when you do domain-driven design, is simple solutions. So let's talk about that. Now, what I think about when I mention simple solutions is the opposite of having this, for example. You have one architecture, and you use that architecture in all the systems that you build. because, it's what you usually do. It's your habit. When you do that, you're in your comfort zone. This is sort of the one-size-fits-all. And another argument I hear a lot is that if we use the same architecture in all places, all developers will sort of recognize the code and the structures directly when they go into a project. The problem is, of course, that we don't think about the problem. So we're trying to solve a problem, and we just apply this ready-made solution to it, regardless of whether it's a tiny problem or a big problem. We don't care. Same solution for everything. And since that solution needs to cover a lot of different types of problems, it's bound to be pretty complex and big. So we end up with big, complex solutions to simple problems. I think about template-driven development and need-driven development as two opposites. When we do need-driven development, that's when we look at the problem and we ask ourselves, what do I need to solve this? What is the minimal amount of stuff that I need? Template-driven development, that is just, you have a ready-made solution, you have lots of code, and you just copy that and paste that, and now you have something going on. Copy and paste, some of my previous co-workers call it sloppy haste. It's bound to go wrong. When you copy and paste, 99.9% of the cases, something won't turn out right. And when you end up with a lot of code that does things that you don't really know anything about. So what happens is that developers doing template-driven development, they will have no clue. And when something goes wrong, because it will do, they don't know how to fix it because they didn't write the code, they just copy it blindly. Another thing is starting out with big complex frameworks. There are many problems with frameworks. Some of them, when it comes to big complex ones, is that they are very opinionated, which means that the framework will dictate how you build your solution. To use this framework, you need to do things this and this and this way. And if you don't want that, tough luck. So, but you say, well, I want to use this framework, and then what happens is that you get lock-in. So at a later point, you say, I want to switch the framework, and you can't do that because you're so tightly connected to the framework that you can't do anything about it. This is not something we should do. This is one of my favorite charts for many reasons. For one, it has no labels whatsoever, so I can just read anything into it. It's fantastic. But in this particular slide, I wanted to represent knowledge. So this is a knowledge during a project. And what I say is that in the beginning of a project, you have very little knowledge. It's not true always, but most of the time it's like that, especially when you come as a consultant to a new customer. So you have very little knowledge, and as time goes by, you learn more and more. This is obvious, of course. If we relate this to something I call solution space, when we're late in the project, when we know a lot, we can choose solutions that are sort of very capable and advanced. So we can have cloud solutions and solutions with many prongs and sides and so on. Because we know a lot about our domain and our problem, so we know that these solutions are a good fit. In the beginning of our project, though, we don't know that. So what we should do there is to select simple solutions. Solutions that are so simple that when we later on determine that they are no longer relevant, they need to be changed, we haven't wasted so much time. So as you can see here, apparently we switched 3 of the solutions to something more capable, but the green solution there wasn't necessary anymore, so we just removed it. And if that had been a big complex framework solution thingy, then we would have wasted a lot of time doing that. I think a lot of us tend to use the solution space to the right, even in the beginning of our project, for many reasons. Perhaps it's what we know, or perhaps we think it's cool. We want to use the cool things, the big cloud solutions, everything, because we want to learn more. So we just apply that, and then we have sort of killed mosquitoes with a shotgun, or whatever the saying is. So choose simple solutions in the beginning and step up as soon as that is the right thing to do. Now, what this allows us to do is to shift focus. So in the beginning of the project, when you know little, you need to learn. You need to learn as much as possible, but not about the technical solutions. You need to learn as much as possible about the domain. So you need to focus on the domain model and work with that, learn more and more about the domain, and handle technical stuff later on. Because in the beginning of a project, the problems that you're faced are guaranteed domain problems. Those are the most important problems that you're faced with in the beginning of a project. And I'm sure that all of you are very much capable of taking any technical solution, implementing that really well. But when it comes to domain problems, all of us are, most of the time, sort of beginners in new domains. It's also about customer satisfaction. So if I come to a customer after one iteration, and on one hand I say, look, I've coded this cool network communication protocol which allows really fast and secure communication between our systems, but I haven't really done anything that you can try out and work with, and it doesn't really adhere to the requirements and so on. That is not the situation I want to be in. I want to show the customer something that is what they want, that they can try out, so they can give me feedback and allow me to continue to work on the functionality that they want, and have just a simple solution that sort of makes that happen. And then later on, I can attend to the technical issues. I can see if my simple solutions need to be changed. And actually, it's quite surprising. If you choose very simple solutions in the beginning, often they fare very well. So in the long run, they are okay, just because they're so simple to use and simple to maintain. So what we did with the client was just this. We sort of followed the learning curve. So in the beginning, we had no layers. As soon as we noticed that we need a layer, for whatever reason, we could justify it, we added one. So I'm not saying that layers are bad. I'm just saying that don't add layers mechanically. So don't start out with 10 layers and just fill them in. Start with very simple things and add layers as you need them. And they had this big UI and service frameworks, and we said, let's not use those. They're quite bloated. They have evolved over a long time. Let's start without them, and then we will see what we need. So let's focus on the domain instead. And we did that, and we kept things as simple as possible. We only included and created something when it was needed, and the result was very good. Another thing that is very important in domain-driven design, as you can imagine, is the collaboration with domain experts. Now, if you were at my colleague Jimmy's presentation yesterday, he talked about something called the team model. And the team model is a good representation of how we as developers should be when we do domain-driven design. So there are two parts to the T, and the horizontal part represents broad business understanding, and the vertical part represents the technical depth. And I think most developers are very good with the technical depth part. Fewer developers are good with the business understanding part, for many reasons. Some reasons are that we're not very interested in it. But if you want to succeed with domain-driven design, you need both. You need both the technical depth and the business understanding, so that you can collaborate with the domain experts. So to become the excellent domain-driven design developer, you need to talk to the domain experts, and to do that, you need to have not only the technical depth, but also the broad business understanding. Now, so what you do when you collaborate with domain experts is, first of all, that you grab one. So you find a domain expert in your organization, and you take that person and sort of assimilate that person into your team for the entire project, so that you have close collaboration, daily collaboration with the domain expert. Who is a domain expert? Is it a role? No, it's not a role. If someone in your organization has as a role domain expert, then you need to be suspicious. A domain expert is a person who has very much interest and experience of the domain, and is curious and wants to learn much about the domain. It can be anyone. So grab one or more domain experts and collaborate with those throughout the project. What happens is that we as developers, when we talk to the domain experts, we learn very much about the domain, more and more over time. And we take that knowledge and we incorporate that into domain model. So whenever we get new understandings, we change the model so that it better fits what we know. That is also why you should start simple. Start simple solutions, start with something that sort of allows you to have tight communication and feedback loops with the domain experts and everyone else, and then change as you go to fit the new knowledge. But what also happens is the domain experts gain new knowledge. So when the domain experts sit with developers and the developers ask all these questions, the domain experts will learn. So they of course, they start much higher, but their knowledge will go up as well. Domain expertise is perishable. You forget after a while. You need to renew, and through collaboration you do that. What also happens in these meetings is that you get new insights about the domain. And when you get new insights about the domain, you modify the model so that it better reflects what you now know. So we did just this with the client. We took a domain expert and we involved that person throughout the project in everything we did. So we had meetings all the time. We test hypotheses. We did something that's called domain knowledge crunching in domain-driven design, where you really take the knowledge and you question it and you say, can we find new knowledge and how do we do that? And the confidence in the quality of the product became much higher because now the domain expert, which also was a requirement person, had much higher confidence in it being a good system that we developed because he was part of the journey, so to say. We also, when we did feature prioritization, we said that the domain expert needs to be there to prioritize, to say which is most important in the domain, so that we only do that. We won't go and do anything until the domain expert has been sort of involved in talking to us about that. Another extremely important part of domain-driven design is the ubiquitous language. And ubiquitous means something that is everywhere. And that means that we use the same terminology across the entire system. So we use the same words, the same phrases in the user interface, in the services, in the code, in the storage. So wherever you look in the system, you see the same concepts. You protect the language within the system. You speak the language in your team so that everyone knows and are familiar with this. Now, it doesn't apply to your entire domain, your entire enterprise, because what we saw before was the concept of bounded context, and that the domain model applies within a bounded context, and that in an enterprise, typically you have multiple bounded contexts and multiple domain models. And the ubiquitous language is also confined to a bounded context, which means that in two different bounded contexts, you have different languages, different teams working on the domain models, talking different languages. There might be an overlap, of course. So if we have the client concept in two languages, that's okay. But it doesn't mean that client in both languages mean the same thing. And this is, of course, extremely efficient when it comes to promoting collaboration. Because to hinder collaboration, speak different languages. To promote collaboration, speak the same language. So to sort of drive the ubiquitous language, we used something called behavior-driven development. Have you heard of it? Yeah, a few? Do you use it? Anyone? Yeah, a few? So what we do is that we express use cases and scenarios in natural language, and not just any language. We express them in the ubiquitous language. We focus on value of the user, the customer, the business, and we involve the relevant stakeholders. So it's not only the developers doing this, but it's also the domain experts and possibly other people as well. Now, what we learned in the project when we did this with the client was that everyone was interested. Apparently, everyone is a language geek. So when you talk about these things, everyone will sort of pick up on tiny details, what phrases mean and how you use them and so on. And we also bridge a gap. So no longer us and them, the requirements people tossing over a requirement specification and the developers trying to make sense out of that. Now we sit together, we formulate requirements on the system and scenarios for that. So we bridge the gap and say that we're a team together. As an example, This is quite typical. We have ATM cash withdrawal. You're at an ATM as a customer, and you want to withdraw cash from the ATM, and the reason you want to do that is that you can get money off hours. I guess today in Sweden at least, the reason is also that banks don't keep cash anymore. But this could be one reason. And then we have a scenario. And this is a scenario that says that there is enough money in the account. So the customer has $100 in her account. She withdraws $60. That's the action in the scenario. And then a number of things should be true. She has $40 in her account. The ATM dispenses $60 and also prints a receipt. And as you can see, I've colored certain words green and other words red. And the green ones are part of the sort of the BDD syntax, if you wish, the BDD language. But the red ones come from the ubiquitous language. So in this ubiquitous language, we have concepts like customer, account, to withdraw, dispense, receipt, and so on. And when we sit down with domain experts and talk about this, we can discuss, is customer the best word? Is customer precise enough? What about account? And so on and so on. And there can be a lot of discussions about this. Now, from the perspective of domain-driven design and BDD, this is where we can stop. So once we do this, we can solidify the ubiquitous language. We can say that we learn a lot about the ubiquitous language and the domain, and that is fine. But we can actually go one step further, because there are tools, BDD tools, that let us run these scenarios as acceptance tests. That means that you have domain experts that can read your test cases and possibly even write or compose new test cases. And that could look like this. So given the example I had before, I have methods that map to the individual steps of the scenario. And the tool will sort of say, when it encounters the first step, the customer has $100 in our account, it will match against the string up in top, which usually is some sort of a regular expression-ish thing. And it will sort of extract the 100 in our case and put that into the parameter of the method so that I can put that as balance on the account. And then I can do withdraw from the ATM, and then I can do an assert that says that there should be this and this money left. So once we have this, we sort of go all the way from the requirements down to the code with sort of where the connection is the ubiquitous language. We can easily see that we use the same concepts in the code as in requirements. So the last part are some implementation notes, and I hope I will also have some time to show you some code if you want to. So I mentioned earlier that we did this whole aggregate serialization. We just took an aggregate instance, serialized it, and put that in the database. That's extremely low tech, extremely low ceremony, no mapping needed. And there are a lot of serialization formats that you can choose from. You have the binary format in .NET. You can do JSON. You can do binary JSON or BSON. You can do protobuf, whatever you want. And of course, as always, that should be chosen. If you would do something like this, performance, how fast can you serialize and deserialize, transparency. Of course, a binary format is quite different than JSON when it comes to transparency, ability to read. And backwards compatibility and so on. For example, when it comes to backwards compatibility, the binary .NET format is quite different from JSON. But migrating between these formats is quite easy. You have one repository reads in one format, and a different repository writes in a different format, and you're all set. Now, what this allowed us to do was to focus very much, or what happens is that you focus very much on the domain model. So essentially what you do is to say that the schema for the database sort of is the types that you have in your object model, essentially. And there are a number of pitfalls, problems, things you need to keep in mind about that, but it's a very simple thing to do. Now, one reason we did that was that the existing solution at the client, they had an OR mapper, and they actually had one case where one person clicked in a GUI, and that led to 90,000 operations in the database. Because no one could really sort of see what happened in the mapping to all the tables and what happened. It was really complex mapping case. Also, of course, compounded by the fact that everything was connected to everything else. So if you have your aggregate design done well, then your aggregates are sort of isolated, and serializing one aggregate instance is not a big deal. When it comes to backwards compatibility, if the schema changes, if you change your class, then you need to keep in mind what happens with the data in the database. And there are a number of ways to handle that. Microsoft has a document on how to do that with the .NET binary format. And there are ways to do that with JSON and so on. But this is, of course, something to keep in mind. Now, another concern that the client had was this is really slow. And what happened was that we had excellent performance. We saw better performance compared to the existing situation. But as always, know your use scenarios. This is not a solution that is viable for all cases, of course. Another thing that the client was worried about was the transparency. We are no longer able to hack the database, go into SQL, the Management Studio, and hack in the table. And the only response I can give is that that's a good thing. Because if you go directly into the database and hack in the table, which I guess is a pretty typical situation, what happens is that you bypass all the rules that apply in the domain model. Everything that you have set up is sort of bypassed, and you can just hack away. So by having whole aggregate serialization, what you're forced to do is interact with everything through the domain model. And then you can just code small programs that dump data to a statistics database if someone wants to have arbitrary statistics from that. So what we did was essentially that we had a small custom implementation, a couple of hundred lines of code, where we saved an ID of the aggregate instance, just a GUID, and then we had the object graph, just serialized object graph. We kept a version of the aggregate instance, version of the assembly, and then a number of columns here. And the purpose of those are to be able to query data, to search for data. So here we could say, give me all the aggregate instances where the region is Europe. So what we do is that we take out selected properties from our aggregate instance and put those as columns next to the object graph. Another benefit with this is that if we want to take out a listing of what we have in the database, if we have selected these columns appropriately, we can actually create list objects that shows us what we have without having to deserialize the entire object graph. This was very successful. And it also meant that we could use SQL Server indexing and everything to keep things as fast as possible. And the good thing with having this in SQL Server was that the IT department was very, very happy. When we talked about MongoDB and stuff like that, they were really, really worried because now they had to sort of use another technology that they had to learn and maintain and worry about. Now we could just keep everything in the same infrastructure that you already had. So backups and everything worked just out of the box. And a few hundred lines of code, no big framework for this, custom written just to fit the use cases that we have, nothing big and fancy. We used expression trees so that we can statically type column definitions so that any changes to the model would be caught by the compiler. And we actually use standard .NET serialization, and we can use serialization hooks. There are surrogate selectors and serialization binders that provide us with the functionality to migrate data and handle backwards compatibility. We also let our implementation generate a schema automatically, which means that we could easily provisioning test data. We could just run this on the continuous integration server, the build server, and that would just clean out the database, set up the database and run tests and have the database set up that way. Extremely low ceremony. So, wrapping up, the result was an extremely simple subsystem compared to what the client had before. It was tiny, a couple of thousand lines of code compared to 10 times that in normal cases. We had a rich domain model. We kept the domain model in focus. No business rules and business logic scattered in service layers and so on. And it was very well tested. We had more test cases, more lines of test code than code almost, I think. It was really well tested. So the reaction from the developers then working with this was that it's really good when they go in and fix things because they get an instant feedback on whether or not they did good. And performance was excellent. in the UI and in the database, everything was just dandy. So we have talked about domain model today. We have talked about a number of DDD patterns, bounded context, ubiquitous language, aggregate, value object, repository. These are patterns that you need to be familiar with if you do DDD. There are a number of books you can look up. Eric Evans has written sort of a famous one about DDD. It's 10 years old, but still very valid. Simple solutions, and don't choose advanced complex solutions in the beginning when you don't know very much. Collaborate with domain experts throughout the project to learn more about the domain, and, very important, to modify the domain model and the implementation of the domain model whenever you learn more. Speak a ubiquitous language. Use the correct terminology. Use that everywhere. This is crucial so that you don't end up in confusing situations when different people use the same word to mean different things. And dare to challenge the development habits. Dare to do things differently when it comes to comfort zone, standard approaches, just-in-case development, and those negative constraints. So, my time is up. Thank you for listening. Please, I'm here a couple of minutes if you have questions. And please do the evals so I can know how I did. And thank you again.